Okay, so I'm going to quickly go over the review. Let's start with this, find the domain and range in the zeros. Remember, this is the V graph. And the order we work it in is left and right first. So we're going to go right 3 and down 3, which puts us there, and there's our V. The domain for the V, remember, is all real numbers, or you can also write it from negative infinity to infinity. And then the range goes from negative 3 up, so greater than or equal to negative 3. Zeros, if you notice, it's got 2. So in order to find them, let's set this equal to 0 and find the 2 zeros. Move your 3 over first. Once you get the radical alone, now your two options are x minus 3 could have given us 3, or x minus 3 could have given us negative 3. So therefore x is 6 and x is x is 0. So these are the two answers. X could be 6 or 0. This is the hill graph, remember? We always do left and right first. This is with x, so we go left and right. So we're going to go right 4, and there's your hill graph. The domain would be x is greater than 4, because we went over 4. And the range would be from 0 up, so y is greater than or equal to 0. Also, if you prefer 4 to infinity, 0 to infinity. Our zeros, look, they have one exact 0 right there, which would be 4. X equals 4. If you weren't sure, you could set this equal to 0 and solve. Okay, these are composition of functions. The plus one is easy. You're just going to take function f and add g. So that's 2x minus 4 plus x minus 2. Just combine like terms. So 2x and x make 3x. Negative 4 minus 2 is negative 6. The minus is the one that gets the star. You have to be careful because you want f, which is 2x minus 4, and you want to subtract g, which is x minus 2. And the negative throws us off because now then we have to distribute, remember? So this is actually 2x minus 4 minus x plus 2. And now combine like terms. So you end up with x minus 2. 2x and x is x, negative 4 and 2 make 2. Right, now for number 5. This symbol right here, remember, means multiplication. So you're going to take 2x minus 4 and actually multiply it by x minus 2. So you have to FOIL. So you get 2x squared minus 4x. And you go the other way. Minus 4x and then plus 8. Be careful. Guys, I just now realized that I did that problem wrong. I apologize. It called for f and h. Okay, I didn't even see that there's an h here. So f should have been 2x minus 4 times h, I apologize, x minus 3. Now let's FOIL it. So you get 2x squared minus 6x. Go the other way. Minus 4x. And then plus 12. Again, I'm sorry. Now combine like terms. You only have one x squared term, so 2x squared minus 10x plus 12. Sorry about that, guys. All right, now go to division. Okay, remember, division kind of gets another star too, so you don't lose points. You have to remember the restrictions. So f is 2x minus 4, and g is x minus 2. Let's go ahead and take care of our restrictions. If you think about this, the denominator is not allowed to be 0. So x minus 2 cannot be 0. So when you solve for x, add 2 to both sides, so x can't be 2. So there's your restriction. Now then, if you simplify this one, you get 2 times x minus 2. I took a 2 out of here. I divided. Over x minus 2. This cancels, and your answer is 2 with the restriction. Now hang on. My answer is 2, and my restriction said I can't be 2. So that gets kind of a double star, doesn't it? So what does that mean, actually? That means that there's no solution to this problem, because the answer I got is the answer that's not allowed. All right, the next one. We're going to take g and plug it in for h. Okay, guys, remember, that means we're going to take this huge guy right here, all of him, and plug him in for this one. So this x goes away. So instead of the x, we're going to write x minus 2. That's gone now. Don't forget about your 3. So, and then also a minus 3. So your answer is actually x minus 5. Now we're going to go a different way. We're going to take g and plug it into f. Okay, we're going to take g and plug it into f. So I'm going to erase what I had. Okay, which means we're going to take this guy and plug him in here. So this x goes away. So I'm going to put my 2. I'm going to replace my x with this x minus 2. And don't forget about your minus 4. Right, so now let's distribute. 2x minus 4 gives me 2x minus 8. Okay? Alright, I don't know if you remember this, but there's given me 3 graphs, and it told me what to do with each one. Okay, so this says half of f of x. Remember, that means you want half of your y's. So you'll notice we'll just take a different color, and I was way up here at 10, so now I'm going to be at 5. Half my y's. This point, I was at 4, so half of 4 would be 2. Again, this was 4, half of 4 is 2. And my y value on this last point is 0, and half of 0 is just back to 0. So when you connect your points, you'll notice it's half as wide, right? Okay, this problem here. Remember, this means flip x, right? So you're going to flip x. But, okay, before the order that we do things, remember, are left and right, flip and compressions, and then up and down. So you're going to flip, and then you're going to go down 2. So flip over the x-axis. This is my x-axis. So in other words, if you were up, you're going to go down. So I was down 1, so flipping over my x puts me here. But then it asked me to go down 2 more, which is kind of strange. Which puts me right back where I was. Okay? Go to the next one. Flip x, which is at 4, so we're going to go down 4. So there, I flipped over my x, and I'm going to go down 2 more. Right? Flip x, and then down 2. Same with this one. I went up 4, so I'm going to flip over the x. I'm going to go down 4. And then I've got to go down 2 more. Flip x, which is there already, and then down 2. Okay? Right, the next one. Do you guys remember here means to flip what? Flip y, correct? So you're just going to flip over the y-axis. This is my y-axis. So if I was going left, you're going to go right. So this start at this point here, and it looks like I was 7 left, so you're going to go 7 right. It's on top of the point, but that doesn't matter. Okay, so that point's done. This one went 4 left, so we're going to go 4 right. And I'm going to connect them. That point is finished. Now go down here. It went left 1, so we're going to go right 1. I'm going to connect. And go up to this point. Looks like it went 5 right, so we're going to go 5 left. Puts this right here. And connect. And this went 7 left, so we're going to go 7 right. And connect. Alright, go to the next page. This says sketch the graph of each function. Correct? So let's go ahead and do what it tells us to do. Remember our order. We're going to do left and right. We do any flips, stretches, or compressions. And then we go up and down. Okay. With x, so you're going to go right 1, flip over the x-axis. That negative is a flip. And then up 4. Okay, this is a parabola. So let's go ahead and take care of that. So we're going to go right 1, I'm here. And then normally I would have a u. fact, I'm just going to kind of sketch one. But I'm flipping over the x-axis, so now it's kind of, I'm going to erase that. You can just think it if you want, and now I'm going to go down. Then it says to go up 4. 1, 2, 3, 4. So there I am, and I need a down, a parabola opening down. Okay? Number 11. You do the problem in this order. Okay, the only thing we have is left and right. So we're going to go right 3. And it's just the shape of a V. So out 1, up 1, out 2, up 2. Number 12. Left and right first. You're going to go right 3. Flips are next, and there it is. So you're going to flip over the x-axis. Remember, if it doesn't actually touch x, right, touching x, in with it, flips over the y. Since it's not inside here, you're going to flip x. And you're going to go up 2. Right, again, this is the V. So we're going to go right 3, which would put me here. I want to flip over the x-axis. So instead of a V, I've got a down. My V is going down. I'm just kind of sketching so I have an idea. And then I'm going to go up 2. So there I am with a down V. Go to number 13. It's a parabola because of the square. Left and right first. You do the opposite. So we're going to go left 2, down 1. No flips were made, right? No negatives. So left 2, down 1, and it's just a parabola. Out 1, up 1, out 2, 4. Okay. 14 is the tricky one. 14 has this big parentheses with a negative, remember? So you have to distribute. You're going to put your negative here and here. In other words, you're going to write the negative in front, and then you change the sign of this. I only put the negative in front. I want the opposite of this, x plus 3, and I want this change. So it looks just like this. Notice that this did not change, plus. I put my negative in front, and I change the sign of the 4. Now if you follow the directions, left and right first, so left 3 flips, so we're going to flip over the x-axis, and then we're going to go up 4. It's a parabola. So left 3, currently I would have a U. I'm going to flip over the x-axis, so now I'm going down with my U, and then up 4. I'm right there with a down, a parabola that opens down. $15 would be left 5, down 2. And it's a parabola. No flipping. There was no negative. Moving to 16. 16 says, graph this function. So we're going to graph this problem. Here, we'll do that in green. Then it says find the rule. So we'll use pink and graph it. Okay, so the original function is graphed in green. Remember, this is the one where they're inverses. So you're going to find f, and then you're going to find its inverse, which means they are symmetrical along the y equals x axis. So I'm symmetrical along this axis here. All right. Let's graph the first one I said in green. So start at -2 and have a slope of 4. So there's my line. Okay, this is f of x. Now I have to actually find the inverse. Remember, to find the inverse, you take the function and you flip the x and y. So this is kind of like y, so we turn that into x. and then we solve for y. So move the 2 over by adding 2. Then I have to divide everything by 4. Everything, not just one part. So now this is called the inverse of y, right, with a little negative 1. Okay, and there's an imaginary 1 there, so we're going to call this 1/4 x plus 1/2. So your new function is 1/4 x plus 1/2. Now let's graph it. Start at 1/2, which is right in the middle, it doesn't matter. And then my slope is up 1/4. Okay, and this is the inverse function. And are they symmetrical? Yes, if you hop from the green to the pink, you're hopping over the yellow line. Well, this is, now I want the domain and range of the pink line, the inverse line. The domain of a straight line is all real, and the range is all real. Same thing for 17. All right, let's graph this first, which means we're going to go right 3. And you have the hill graph. Out 1, up 1, out 4, up 2. Here's your graph. Then we're going to find its inverse, which that's what the negative 1 means. Okay, we're going to find the inverse and graph it. Inverse we'll find in P. So we're going to change the f of x to x, right, instead of y, and change the x to y. Remember, you switch x and y. Now you're going to solve. I'm solving for y. So in order to do that, I'm going to square both sides because that's what's going to get rid of the radical. So now I have x squared equals, and squaring it just drops the radical. You don't need to change 3 to 9. You just drop the radical. Now move the 3 over, and now you have the inverse. So the inverse is x squared plus 3. Now remember this. There's a problem here. This is a parabola, right? So if you tried to graph this, x plus 3, it looks like this. Correct? But we can only have part of it, remember? So if you erase this part, that's the part that's allowed. Now look at it. Are the inverses? Yes. Hop over the yellow line. So this is all we want. Okay, so there's a restriction on the domain. On the domain, x has to be greater than or equal to 0. I'm talking about of the pink line, in order for it to be the inverse of the green line. And the range is y is greater than or equal to 3. All right, let's go to 18. Okay, so for problem 18, you'll notice it already has a restriction. So it's not going to actually be... Okay, so we have a parabola, correct, with a restriction. So I'm going to use my pencil to start with this, because the parabola tells us to go left 2, and it would be this spot here. This is the parabola. However, it says x has to be greater than or equal to -2, which means that the left side of the parabola is going to be gone. Here is your picture. Now it tells us to find the inverse. So we're going to find the inverse, remember, by the original problem is this. We're going to switch x's and y's. Right, to get rid of y by itself, to get rid of a square, you're going to take the square root of both sides. So that gives you the square root of x equals, and it drops the whole thing, just y plus 2. Remember, squaring it drops the square. Now move the 2 over, so the square root of x minus 2. It's not inside the house, it's outside. Now here's the inverse. If we're going to graph it, so this is my original function, this is my inverse, we're going to graph it. We're going to go down 2, and it's a hill graph. Up 1 over 1, out 4 over 2. Okay, and if you actually took the y equals x line, you'll notice it is a mirror image of that. It would just be a reflection over the y equals x line. Now I want the domain and range of the new function, which is the inverse function. The domain would be x has to be greater than or equal to 0, and the range, you'll notice, is greater than or equal to -1. Or 0 to infinity, -1 to infinity. Now going to this part, graph the piecewise functions, remember? It's good to start with this with a pencil. This is x squared, so this is my x squared, a parabola. And then it's going to give me a restriction, -2 to 1. So I'm going to find on the x-axis at -2, I'm right here. There's -2. Then you go and find your graph. So I'm here. And it tells me it's a closed circle. So -2 up here, closed. And we erase the rest because you can't go past that. Then you go to 1. Here's my x-axis at 1. Find your graph. I'm here. It says I'm closed. So anything past that, I'm going to erase. It's my first graph. Now for my second. You graph this line. It starts at -1 and has a slope of 2 over 1. Up 2 over 1, up 2 over 1. Notice it crossed that point. It's okay. I'm just going to put a bunch of points there. Now let's check the domain. It wants x to be bigger than 1. So put your pencil on 1. Go to the graph. Well, here's my line. Go to the graph, and it wants an open circle. Well, there's already a closed circle there. That's fine. Just put an open circle there on top of it and go, which makes sense because the parabola is closed there and the line is open there. Therefore, it remains a function. Erase the rest, and there's your piecewise. Number 20. First graph this, starts at 7, and has a slope of -1. Okay, look at your restriction, x of domain. The domain says x is less than 2. So here's 2. Go to my picture, and at 2, I'm going to be an open circle, actually. Because it says less than. It did not have an equal to sign. It was just less than. And it says you want x to be less than 2. Less than 2 is to the left. Right? Erase the rest. Now go to this problem. Start at -3. My slope is 2 over 1. There's my line. This says x is greater than or equal to 2. Here's 2. Find your picture. This time it's closed. And what's greater than, which you go this direction. To the right. X is bigger. And there's your function. Okay. Now, on this one, there's a typo here. Let's make this an open circle, and that will fix it. You have to write an equation for each line. So start with this one first. This is a parabola that we've moved over 3. This would be x plus 3 squared. And we have a restriction. And it looks to me like it went from here to here, which would be from -5 to -1. And they're both closed. So -5 less than or equal to x less than or equal to -1. Now let's describe the easy line. This is the easy one. Remember, I moved this to an open circle. It's just a straight line at 6. So that means y equals 6, right? So we put a 6 here if, and we want x, here's my domain, we want x to be greater than 2. And I made that an open circle. So here. Now this is the hardest one because it's a line. Remember, to write an equation of the line, we need the slope and we need the y-intercept. The slope is, looks to me like if I pick this point and this point, they went down 2, right 1. -2. And the y-intercept is -3. So my line would just be -2x minus 3. For my restrictions, I went from -1 to 2. Open, enclosed. Okay. Last part. It's asking if they are inverses of each other. Remember, if they are, you'll get an x. So you have to do two things. F of g of x first. In other words, you're going to take all of this and plug it in for here. This goes away. So I'm going to write 2x plus 3 minus 3. Right, don't forget your minus 3, all over 2. Which gives me 2x, these cancel, over 2. 2's go away and you get x. So you're good, that one works. But now you got to check the other direction also. Right, so I'm going to erase this. And we're going to go the other way. This big fraction into here, right? F into g. So the 2 stays, this x drops, and this entire fraction is put in its place. Don't forget about your plus 3. Drops, x minus 3 plus 3, goes away, and you get x. Okay? Therefore, they both were x, and you're going to get a yes. Guys, for time on the video, you get yes here also, but I'm going to move on real quick. Domain and range. The x values here would be all real numbers. The range would be from 0 up. The domain here looks to me like it's about -6 all the way to maybe 9. And the range goes from 0 to 9. Domain here is from 0 to infinity. And the range, all real numbers. All right, that's it. Thanks for watching.